Well, hello all, and this is going to be an interesting session. And please forgive me. Appreciate those of you who joined on and joining on. This is the very first LinkedIn Live presentation that I've done. But why have we pulled this together? I think really because the passion and the DNA of the organisation is saving lives, and particularly in regards to Arc Flash, electrical safety, dear to my heart. And I thought, well, why not just set on a brief Arc Flash awareness training session for everyone and anyone to get the benefit of it. So what I'm going to do now is keep moving through, put your comments in there, and appreciate you being with us. So from Scanware, I think the key thing focused exclusively on any organisation that's working on or near live or potentially live electricity, manufacturing arc and flame protective clothing under the Strata Protection brand, and one of the largest stock collections of arc and flame protective clothing globally, 4 locations, 82 locations are delivered to, 8 languages spoken, and client base fundamentally across the energy sector. So anyway, enough on Scanware. My name is Angus, Technical Sales Director, but it's not about that. It's about Arc Flash. That's the key topic. So what I'm going to do here is just play a little brief video for you, and please forgive me as I'm going through this if I make any bloopers. It's new for me. So let me just get this playing away and see how we go. Okay. So what this is showing us here is the impact of an Arc Flash. On the left-hand side is arc and flame protective clothing. It is our particular clothing being tested in Kinectrics in Toronto, a test lab. On the right-hand side is regular polyester cotton. And what the thing is, the statistics tell us that more people die and are injured from burning clothing than the actual Arc Flash situation itself. Because we're all aware, an Arc Flash is a huge, intense amount of energy, 19,000 degrees centigrade or 35,000 degrees Fahrenheit, and it's ejecting. And so fundamentally, providing there's a bit of space around, is knocking the engineer back onto the floor, likely to put them unconscious. But in the event of the engineer wearing, even as a minimum, high cotton content or flame retardant clothing, then at least they're going to be avoiding some of the risk of catching on fire. Certainly from an arc and flame protective clothing perspective, they're not going to be sitting there burning. So for those in the wind sector, Tom de Glac onshore wind farm in the UK, 2020, they had a really terrible electrical safety situation, and that was entirely down to the burning clothes of the affected engineer. So not only have you got an engineer with severe burns, but also you've got 2 colleagues who suffered terribly from the trauma of having to roll a colleague out on the hillside in Scotland. So let me just get back to where we are. One moment. So let's keep going. So I'm kind of doing this a little bit solo. So any questions, anything you want me to be slowed down on, just put a message into the chat, and we'll try and do what we can to answer the questions and support. Let's hopefully enjoy. So I'm going to play a little brief video here, 5-minute video, live story of a particular electrical engineer, know him well, based down in Tampa in Florida. And I think the key thing here, and it resonates with many, he'd been a seasoned electrician, been doing his job for many, many years. And as we all know, an Arc Flash situation is really, really low frequency event. More frequent than we may choose to admit, but in the main, it's low frequency. But the consequences are devastating. So let me just run this video through with you now, and let's see how we go. Oh, one moment, let me just get the right one.
I got up early that morning. I was going to go to work to hook up a generator before the Hurricane Charlie moved into Florida. When I left that morning, I just figured it was any other day. I guess you don't wake up in the morning thinking that you're gonna be in an accident.
911, what's your emergency?
We need an ambulance quickly. We just had an accident.
Sometimes when you get in that kind of situation, you kind of just have to break it down to the hour and the minute, because if you look at the whole day, it's pretty overwhelming.
What's the problem?
My coworker, he's badly burned. He just got caught in a fire.
Is he
Flash arc fire.
Is he conscious?
Yeah, he's conscious.
I haven't done this 1,000 times. I've been an electrician for 20 years. I didn't need to wear my gear that day. I guess I was too good for it.
Can you tell me how many have been injured?
He's the only one, but he's in shock. He's got severe burns.
Donnie's service call was to go out, hook up the wires from the temporary generator into the main panel, which he's done many times over.
My job for the day was to hook up a 3,000 amp generator to a 3,000 amp electrical service. After I tested the generator power, I went into the main building electrical to test it. And I opened up a small panel for their main switchgear, their main breaker panel for the entire building. I clipped A phase with one alligator clip. I clipped B phase, and as I went to clip C phase, the meter blew up and blew a puff of carbon into the electrical box. Well, this set off an electrical explosion between all three phases.
We got a phone call that there was an accident. I was told that there was a flash in the electric room and the electrician on site was injured.
I didn't realize at that time how badly I was hurt. The one maintenance man told me later that he thought I was dead because there was no way somebody could stay alive through that explosion. Looked down at my arms and hands and I realized I was really burned up this time.
They told me my husband was calling, but it wasn't. It was another man. And he just said, I just have to let you know your husband's been in an accident. He'll be going to Tampa General, but he is walking and talking. I just literally threw the phone, grabbed my purse and ran. And all the way down the road to the hospital, I was wondering, who do I call? What do I do?
One of the first things I thought was, this doesn't happen to me. You know, this is something that you hear about in the safety films or somebody's friend that had this happen to them. It doesn't really happen to me.
They didn't recognize him because he was charred black. That was hard to see. Then he started getting infections. And I remember sitting there being talked to as if he may not make it through this. His waking up was very slow. It was just opening the eyes at first and not really being able to talk. I think he, like the first day, he was asked to respond by blinking.
After that point, they tell me I was asleep for a month and a half.
Once he woke up, I felt like, okay, now we're getting better. Now it's on the way up. And I don't think that any of us realized how long the recovery would be.
One of the first memories I have is my son walking into the hospital room across the foot of the bed.
When I first talked to my dad after he woke up, I saw he was definitely still the same person, but his body was just so small and shriveled, and he'd been through surgeries at that point. Later on, the number would total to about 6 or 7, and he'd have to go through hours and hours of therapy and rehab. He had to relearn how to walk. He had to relearn how to use his arms.
You know, I told my wife once before we got married that as long as I had these, we would have money. Well, I almost didn't have these. I almost lost my life altogether because I wasn't wearing the protection.
Less than 3 minutes of putting on his safety equipment would have prevented him from being in a coma for over 30 days, as well as a year-plus recovery.
Being safe is a lot easier than putting yourself through and your friends through and your family through what my family and I and my dad had to go through. It's just easier to put on your safety equipment.
If he would have taken that 2 to 10 minutes of time to put the gear on, work a little bit slower, it really makes you think that it's okay to be a half hour late.
As fortunate and blessed as I feel today, I could have avoided all of this that I put my family through, that I put myself through, if I'd have just taken that 3 minutes to wear my PPE.
So I think there's some key messages in there. One of them being is this: the fact that he'd done the job 1,000 times before, this kind of thing doesn't happen to me. And I think we hear that and it resonates across industry. So from an actual Art Flash clothing perspective, so you might say, well, why is this used? Why is this worn? And I'm going to cover off in a few moments about the fact that it is your last line of defense. And obviously there's a hierarchy of controls that we adhere to. We're going to talk about that. But I think the bottom line is there are no known fatalities of anyone wearing the correct Art Flash clothing protection and PPE. So I do think that it's an excellent backstop, of course. So how big an issue is electrical safety? So I'm conscious that we're approaching a global audience from a UK, European, and North American, Asian perspective. But just if we look at the UK for a moment, 2020 was a bad year. We had Scottish Power fatality, Northern Electricity. I think we had another one as well within nuclear. But I also just think it's very, very hard, particularly in the UK, to try and get your handle on some statistics. But there's 3 slides here that I think you will find of interest. So one of them, I appreciate this is going back quite a few years now, but there's a conversation with an ex-electrical HC inspector, and he said between 2001 and 2009, this is in the UK, there are 162 electrical injuries in the south and east of England, of which 38 were fatal and 92 were serious. And they're the ones that you may say came across his desk. And so I think what it's really telling us is that there is a real gap in any kind of reporting of what the true impact of electrical safety has to the population of the UK. And we can broaden that out across Europe. I think in the US, they're good at capturing the statistics. But this is a reality. So I've been at a wind energy event for the last couple of days across in Manchester for the offshore wind sector. And if we look at offshore and onshore wind, which is a key marketplace for us, you can see here in 2021, they had a 10% increase in electrical related incidents. And so you can see that it's the 3rd highest risk activity that ladies within the offshore energy, within the offshore wind industry are encountering. And if I move that onto the onshore sector, exactly the same situation carries again. And there you see that it is actually the number 1 highest risk or incident activity which has been undertaken is working on electrical systems. That's within onshore wind. So that's data that we've got, which really clearly tells us that there is a need of addressing electrical safety, art flash awareness, which is why I'm putting this session on now. And as an organization, we invest thousands of hours globally each year on just raising awareness around art flash. And so I'm going to play a little story here now. Again, another testimonial, which I think you'll find, I think you'll find interesting.
I've been an electrician for about 18 years now, and I'm very confident in what I do, and I still ended up in hospital. I've got up that day, the standard day, not thinking anything of it. I says, I'll bounce in and do that power quality assessment we had to do. I'd assessed the work to be done live, and I was very confident of what had to get done. It was possible to do it live. All I need to do is clip on these 4 crocodile clips, which isn't a hard task, you know what I mean? I can see the buzz bar. I've clipped on the first one, and then I've went to clip on the second one. And as soon as I've touched it, it's just went, just white, yellow flashed, you know what I mean, in my face, and just a really disgusting noise. I wasn't unconscious, but I sort of realised what had happened, and I could just smell it. All my hair burnt, my skin was all burning, and I could see all my clothes were burnt and things. My skin was hanging off and that, and I was just all black.
So when I first found out that he'd had the accident, I was at work, but when I answered the phone, I couldn't actually understand what he was saying. He was all gibberish, but all I got was, I'm in a bad way, I'm being taken to hospital. That just panicked, yeah.
In Mark's case, while he was working in the switchboard, as a result of attempting to pull off 2 pieces of insulation, he exposed the risk of 2 separate electrical phases. In bridging that out with his screwdriver, he's created a large arc flash with high fault current available inside the switchboard, which resulted in a large fireball which burnt Mark considerably.
When I first walked in to see him, he was in a hospital bed and he was just black, and his hair was singed. And
the injuries that I actually sustained would have been, it was actually 12% body burns, so that involved skin grafts. For that to heal, they cut all they grind your skin off and then lay that on top of the burns.
So the next day after the skin grafts, as soon as I walked into his room in the burns ward, he was just head to toe in bandages. He looked like a mummy. I think that's when it hit me.
The first week was not an enjoyable time. I was on splints, you know what I mean, full arm splints, leg splints, couldn't even pick my own nose. Every second day I had to get all my dressings took off. So you've got dressings stuck onto skin grafts or sticking to you, so you need to go into a shower and then get all wetted up to release like all the stickiness of it, and then take it off, and it just sticks to your skin, and it's sore. I didn't know what I was going to look like. I ended up in hospital for 3 weeks and off work for 3 months. And what I didn't realise then, due to what I was going through, how it had hurt Mel, how it had emotionally strained her and mentally and emotionally. It's not a nice feeling to know that the person you love is obviously upset and hurt because of what's happened to you.
Mark definitely didn't realise how much his accident had affected me. A realisation of how serious it was. He could have died. Yeah, just had no idea. When Mark started having his rehab, that was hard because he had been in hospital for such a long period of time without moving. He was really happy when he called me that he told me he'd walked for the first time with a Zimmer frame, so he still had to lean on it, but I was really proud.
There's also a big emotional burden that's getting put on your loved ones, whether it be your wife, you know what I mean, your family, your parents, or something like this puts an emotional burden on them.
He loves his work. He loves to be always, keeping his mind active. So when he couldn't go straight back to work, that also held some frustrations and a little bit of anger. I was really happy to see him back at work. I do want to be with him for the rest of my life, so I am grateful that he is healed.
You can prevent arc flash by eliminating the hazard. Turn the power off and isolate the equipment, even if that means rescheduling the work for another time. Remember, working near energised parts can be just as dangerous as performing live work. Arc flash risk isn't just limited to large switchboards. They can also occur in smaller switchboards, electrical supply pillars, and even large electrical equipment. So plan your work and always follow your safe working procedures.
Yeah, I think one thing that I would like to get out there after my accident is just to all the other Sparkies out there, just don't work live. Don't put yourself in situations where, or like I was, just because you're trying to please the client, just because you're trying to get the job done faster. If you've got a wife, kids, family, it's just not worth it. Nothing's worth your life.
Yet another incredible story, but I think we can all bring this closer to home. And what I'd like to just chuck out there as a question, it'd be brilliant to get some commentary on that, is what are we going to do to fix the, you may say, the lack of awareness, the lack of training, the lack of teaching around electrical safety here in, I think, particularly in the UK. Why? Because I know that market plays the best. There is a problem. As I say, there's two issues. One relates to just the lack of awareness. And so a live case example that I've had in recent weeks was at a large manufacturing producer in the north of England making paper products, and significant plant. Inside the plant there was 22 electrical engineers, and one of the senior electrical engineers had called us through to have a review of arc and flame protective clothing. I went in there, and the electrical guys had got nothing, and the question arose as to why these guys are just, so how come these guys are still wearing just the regular polyester clothing and trousers that they're wearing? They said, well, what do you mean? I said, well, these guys are, they're working in a dangerous environment. They're working on low voltage, and they're working on high voltage, 415s. And the question they came back was, well, they're only working on LV networks. I said, well, Exactly. That's the way the risk area comes through. And then one of the electrical engineers said, hasn't mentioned the guy's name in the permit office. Hasn't he had an arc flash? And all these guys look a bit aghast and turn to him and they said, oh yeah, that's right. And he said, oh, that's why he wears his long sleeve tops. He's got burns in his arm, but that's why he's in the permit office, because he got his drill one time and he was just, I don't know the detail of what he's doing, but he was drilling through the back of a panel and touched the electricity, and effectively this thing just blew up in his hand. And what really shocked me was that these electrical guys, a lot of them, I'm 37 in age, but these guys were around my age, and a lot of them were younger, aspirations years ahead of them, and just the lack of diligence from this particular organization in doing something for the safety of these guys. And that's when I just thought that there's just a blank in the UK in particular in regards to understanding the serious risk that we're facing from an electrical safety perspective. Sorry for the ramble there, but I'm bothered about it. When I turned around to the buying person there, I said, I don't care who you buy it from, but I said, you have a moral obligation to do something, because at the moment you're putting these guys to work, and I said, it's a death trap. So what is an arc and flame protective clothing? It's not a bomb suit. It's your last line of defense. It's not a primary level of protection. The fireman will use the analogy. So he is literally walking into, you may say, an inferno to pull someone out. He's aware of the risk, and his clothing is designed specifically to protect him from the flames. When I look at what is arc and flame protective clothing, I call it the last line of defense. And so I always like the analogy of a striker running on goal, for example. You've got a midfield, you've got a defense, and then a really clever striker. He's dribbled it round, he's running on goal. The last line of defense is the goalkeeper, and that's effectively where arc and flame protective clothing comes in. As I've made it really, really clear there's more and more work and emphasis, which is excellent, which is being done to eliminate, designing in safety, designing out the arc flash risk. And but I just do think that there is still a whole lot of work to do around arc and flame, electrical awareness, so that people they're focusing on it. They're applying time, they're applying budget, they're applying resource to remove the electrical safety risk where possible. Now, if I just quickly move, I'm conscious I'm going through this pretty fast, but if I move on to very quickly arc and flame protective clothing, so it is category 3. What that means is rubber washing up gloves that you use in the sink at home, everything pretty much Europe, UK has to have a CE or UKCA mark. That can be a category 1, which is very basic. Anyone can manufacture these kind of very low safety related products. Intermediary, these are safety products which are being manufactured, and they are for deemed as non-life threatening risks. And so hand protection, for example, falls into the intermediary category. It's unlikely that someone will it's unlikely there'll be a fatal situation in when someone's working with their hands as far as cuts, etc. But flame retardant clothing to protect against welding flash, for example, or welding sparks, that falls into the intermediary category again. And again, certification process is pretty simple, and there many organizations can produce these kind of intermediary products. Complex PPE, you've got arc flash clothing, height safety, life jackets, people working with molten steel. So it's designed to protect people against potentially fatal situations, and the accreditation and the auditing process that has to go all the way through the production of these kind of items is pretty intense. So I'm just going to play a very simple video now, just demonstrating how an arc flash actually works. So it'll start playing in just a few seconds. An arc flash itself, I've already mentioned 19,000 degrees centigrade. Heat of an arc flash, hold your index finger 1 centimeter above a naked flame for 1 second. That effectively is 1 cal per centimeter square of hurt of burn. And that particular arc flash there was a 14 cal arc flash. But I think it really shows you the intensity and the heat that's given as a result of an arc flash. I think also a topic in itself, I'm doing this at a very, very high level from a arc and flame protective clothing perspective. You've got the closed box arc test and also the open arc test. Certifications, IEC 61482, class 1 or class 2 for the European market. And then you've got the ASTM 1506 testing for the North American marketplace. And then now there's also a lot of other additional garment certifications that can be undertaken. Can become a bit of a minefield, which is why if you are choosing arc and flame protective clothing, to do it wisely and align with an organization that can help you understand, I'm going to say help you understand the complexity, but also make the process simple. So I've already briefly touched on the certification perspective, but all garments certainly sold within Europe and the UK have to be fully garment certified. They have to have the full garment tested. and I'll reiterate the piece in bold red at the bottom, that all arc flash protective clothing are flame retardant, but not all flame retardant clothing is arc flash protective. Now, I've already played this video right at the very start, so I'm not going to play it again here, but there are two different varieties of fabrics. And so treated is when you have a cotton or a cotton nylon, 8812, for example, and it has a chemical treatment applied, it's washed into the fabric, and fundamentally, over time, this treatment is deteriorating and washing out the fabric, and you have to have very specific washing instructions to ensure that the chemical protection isn't being harmed by any bleaches or softeners that are being used in the cleaning process. Moving on to inherent, Scanware as an organization is only working with inherent products. This is when the actual protection is contained within the fibers of the product themselves. This means that no matter how the garments are washed or how many times they're washed, the protection is inherently contained within the product itself. And so certainly for organizations in a service business where they have engineers that are working around a country, around a region, around the world, laundering in their own home laundry or offshore in an offshore on a rig or on an SOV vehicle, if it's on SOV vessel, if it's in the wind sector where you're putting your clothing into you may say an industrial laundry, you have that peace of mind. You will never, ever lose the protection contained within the product. So how to wear the product. I think I probably should have said how not to wear the arc and flame protective clothing. This guy here has got no eye and face protection. He's got no neck protection. He's got no hand protection. I probably think he needs a substance abuse test as well, because he's looking a little bit sleepy. So from how you are supposed to dress, of course, this guy's suited and booted for his work, but some of the obvious things, obviously, is ensuring that your sleeves are down, ensuring that you've got the relevant neck protection, ensuring that, obviously, you've got your hand and face protection when you are actually carrying out the work, so making isolations, switching, proving dead, and you can see he's got the right equipment on there. I think also some of the obvious things that we're seeing, particularly in the utility business, is ensuring that the clothing is fit for purpose. If the clothing's too hot, if it's too warm, then what you'll see is people unzipping. You see coveralls tied around the waist, leaving polyester football tops underneath and things like that. And again, it's a bit of a death trap. And this is the effects of inappropriate PPE. On this guy here, you can physically see the red markings of his vest that he's been wearing underneath his clothing. This is a bit of a trap that we commonly see. The guy's got his arc and flame protective clothing. His employer may have done the right thing to give him his arc and flame protective clothing, but unbeknown to the actual engineer, probably because he hasn't been taught, he's wearing a polyester soft shell jacket underneath his arc and flame protective coverall, which completely defeats the object and actually creates a new hazard, because in the event of an arc flash, actually you're going to have a garment burning inside an arc and flame protective coverall. Thanks for the comments that have come through, and Graham, shout out for you. Really appreciate your feedback there. And I'll also give a big punt for Graham Hogg. He's on the. I can see him on the call here today. Anyone that's got any electrical safety queries and questions whatsoever, then you want to reach out to Graham Hogg. He's always willing to help everyone and anyone. He's absolutely on the same mission as we are, as many other people are on here as well, actually, that I can see. Some of the names are familiar. It's this Saving Lives mission. We will share any content that we can to help anyone out, to raise awareness, to protect people, saving lives. Everyone has the right to go home safe every single day. This is a bit of an unusual video I'm going to show here. This kind of slide deck is something that we would commonly be sharing in a complimentary way with clients around the world. We adapt it into different languages. We can adapt it to different content, but we use it and share with our clients so that. And this is a very relatable video here. Many of you can relate to the Ronan Grosjean, the race. This isn't actually him here, but I'm going to play a short video now with him, and I'm going to point out a few parts of this video. So if I can hopefully try and add that in, can I? So let me just move forward. Here we are. I found the right one now.
A big fire there as they exited out of turn 3, and that looks very nasty indeed, and unsurprisingly that is a red flag. Now this is after turn 3, and you see Grosjean, one car out there, and then Grosjean to the right hand side. Going
My God, it's torn the car in half. No wonder the fuel came out of it.
Yeah.
I said the fuel was in the middle of the car, and it's literally...
Whoa! And he's just gone straight across Daniel Kvyat there, as you can see.
That's extraordinary. Yeah.
Just the car...
It's gone through the barrier, you see. The car's gone through the barrier and that's then been sort of used as a wrench, as it were. Unbelievable.
Car now and talking away. There was a tyre that came off and went over the barrier as well. And there's that tyre, as I said, that had gone leaping over the barrier and has ended up.
See, the tethers are brilliantly strong. The barriers.
Yeah.
Extraordinary.
Well, the halo saved his life.
He's gone to the hospital now for the checkups and x-rays and things like this, but he has got minor burns. But
I think that's the key thing to focus on. So what we say to the guys when we're talking to them, sorry, I keep on saying guys, I'm using it in a bit of a unisex sense, but for men and women that are out there within the field working, it's a very relatable diagram. Why? Because a racing car driver, I mean, how many times can anyone on this call remember a situation like that? I think probably one of the situations, I've forgotten the guy's name now, was it Nürburgring, was it back in the 1970s or 1980s? And what we're saying is it's a very, very, very low frequency event, but a driver would never go out with the necessary protection that he needs. And of course, we appreciate the halo saved Ronan Grosjean's life, but likewise, he'd have never have got out of that situation if he hadn't got the right PPE on. And I think it's a very relatable video to be sharing with people. He walked away with minor burns. If he didn't have the correct protection on, he'd have never have walked away from the situation. And I think it's something that we can all use to get the message across, which is why we appreciate these situations are low frequency, but the consequences, as we're well aware, can be devastating. So I'm moving through now, and I'm close to being completed. This is just a short, brief video that we put together, and it's really people are wearing. Some organizations have achieved a level of maturity when it comes to the arc and flame protective clothing, but a common area is the head, hand, and face protection. And often the theory or thinking behind it is for engineers is it's too much hassle. The dexterity is not good enough, and so they just cut corners. In the event of an arc flash, the first things to go up is the hands and in the direction of the face. I'm just going to play a short video here now, and I think if I can hopefully try and choose the right one here. Here we go. Minutes after. Sorry, I don't think it was that one. Let me just. I'm not sure I can flip up the correct video here. I'm probably missing something, but we can share that with those of you with those of you afterwards. But last but not least, this is we're pulling together a new survivor video at the moment. So this story here is utility worker. He worked for 13 years, and he'd fought, should I say, for 13 years in Afghanistan. He'd come back as a utility contractor working for Thames Water, and he was connecting waste into understandably into a waste sewage pipe, and when they'd been scanning the ground, the link between the soldiers was the fact that he'd been in the military and he'd experienced some of the worst situations that you can be in, and he'd come into the utility sector, and the last thing he thought was such a devastating situation had happened to him. So as explained, he's connecting wastewater, obviously, into the sewage pipes down on the street. It was a private connection. And he CAT scanned the area, the ground around where he's about to dig, and he could detect the electricity there. So he said to his guys, there's two guys working with him, he said, I'm going to hand dig this. And he did. He hand dug it himself, came down to just a small LV cable, completely unsheathed, uncovered the ground, and uncovered the cable. And then he thought, well, this is it. We're good to go now. But he still hand dug down until he hit clay. And sure enough, the pipe was there. Now, I believe those are more intelligent maybe on this call, but they go up and they put a dye down. Sorry, that's right. He was working on fresh water. So they put a dye down to make sure that they were connecting into the correct pipe from further upstream. And anyway, he didn't have a core drill, but this is to see what color dye was coming through the water. So he didn't have a core drill. So he just stitched drill. So he just drilled, I think, 5 little holes. On the last hole, as he pushed his drill through, there was 11 kV cable running inside the sewage, inside the sewage pipe. And this is a very short video I'm going to play. And when he talks about HEMS, that's the London Air Ambulance, and you'll notice he's got 2 tattoos on both arms, and they're the names of the Air Ambulance, London Air Ambulance paramedics that saved his life.
9 call, HEMS was sitting down with me, sort of literally starting to give me first aid. And I remember really panicking and just telling my best mate, take the phone and phone Sarah. Sarah's my wife. Sarah's my wife. I had to take that phone call. She had to take the phone call and listen to me screaming in pain. And as a soldier, I never ever thought Sarah would have to listen to that.
Now, I think the important thing is, so I said, this is, he'll just become a statistic, but not only that, he'll become a statistic as a burn. So from a statistical perspective, you'll never know the number of people that are being impacted by arc flashes around, I'd say, whichever country you're on, represented on this call. And this is just, one of many individuals whose lives have been impacted forever by coming into contact with electricity. And so I think this really brings us to a close. And the key message is, of course, is going home safe. And I appreciate everyone that's joined on and bearing with me. It's the first LinkedIn Live event that I've ever done. I hope it's come across okay. And please, guys, just be glad of any feedback. And if any of you want any more information or you'd like something like this done for your own organization, then reach out to us. As I say, they're completely non-commercial. And I think hopefully you've seen in there that no products were promoted, etc. All we want to do is just spread the message of saving lives and just doing what we can to reduce the number of electrical injuries that are occurring each year. So I think probably there's some questions that have come in here, so I'll try and answer some as I go through. What have we got here? Sorry, I'm trying to get down through here. Thanks, Graham, for your comments. Is there a comparison between US standards and EU standards for clothing? There is, but it's not a direct correlation. So what I would always advise organizations is fundamentally your arc thermal protection values, your ATPV values, your cal per centimeter square is recognized. To be able to get an ATPV value, then you need to really have got a US test in the garment. And sorry, my brain is a little bit fried just at the moment, but I can quote the standards back to you, Charlie. F1506, which is the US standard, that'll give you an ATPV rating. And it's also recognized as good practice in Europe now to have garments that actually have an ATPV rating or an ELIM or an EBT value, all of which give you a cal per centimeter square. So, for example, an 8 cal per centimeter square t-shirt or a 10 cal per centimeter square pair of trousers. So you cannot wear US certified only products across in Europe, but you can wear a European product, IEC 61482-1-2 class 1, for example. And if we're specifying clothing, we'd always recommend that you're specifying a minimum cal rating as well. So, for example, I want a pair of trousers in IEC 61482-1-2 class 1. That meets your European or UK compliance requirements. But then also at a minimum of 8 cal per centimeter square or a minimum of 9 cal per centimeter square. In doing that, your products are then conforming with the standard set out in NFPA 70E. So I think that I hope I'm probably skimming this quite lightly. There's maybe more in-depth detail I can give you, but certainly there is elements of harmony between the US and European standards and something that can be shared. And from our perspective, we're always developing and producing products that can be worn just that from a global standpoint. Engineers can travel around the world and are compliant within the regions within which they work. Hannah has asked a good question. Possibility of using wool and merino as an arc flash base layer. I think that's excellent. So, of course, you can get arc flash merino wool undergarments, but even as a standalone, they still offer good protection. Sorry, so I've got some more questions here. So I think I probably missed some question. We have employees working in both regions, but for example, if US guys travel to EU with their arc flash gear, they are covered under the legislation. No, if US guys are traveling to the EU, then they're absolutely not compliant to the European standards. And unless the garments have an IEC 61482 certification. And I think a very important thing to be careful of in all regions around the world is watch out for the wording. It needs to be certified to. There are garments that are being used there are garments that are being used around the world in Europe, and a bit of a backdoor is to say that the garments conform to the requirements of, and that is incorrect. The products need to be certified to IEC 61482, and they should have the standards labels clearly inside, and the vendor should be able to very clearly provide the certification that goes along with that. What have we got here? What energy rating of PP would you recommend to a worker working in a 66 kV or 400 kV GIS substation? A very, very challenging question to ask. Now, I don't know, Ben, if you're on the call, you could stick my email address into the comments, and Rapali could drop that comment through to me, and I could go back with some indicative steer. But I'd probably like to put that out to someone like Graham is on the call, who I'm not an electrical engineer. I understand the basics from an electrical perspective, but there's someone out there who'll be able to probably give a good indication. Clearly, you're working in the transmission business, so it's high energy, and I think I'm probably losing myself a little bit here. So then if you can put it in the comments, or Rapali, you can reach out to me on LinkedIn, and I'll do what I can to try and support and help you on that one. I appreciate the question. What minimum class art flash rating would you recommend for HV engineers? We currently use class 4 as a minimum. Okay, I think it's a good question that you raise. I think when you're talking class 4, I assume that you're using that for relatively short periods of time. I think there's a separate topic that we've done, which is around human factors. You've got to consider what is practical for the guys to be wearing and using. And so if the guys are working for short intervals, then of course, if you're working in a HV situation, and depending if you're working on old switchgear, for example, as opposed to modern switchgear, that's got arc flash venting or arc flash mitigation already built into it, and I always reckon that category 4 is a safe option when you're making the isolation or when you're switching, for example. But it's not practical to expect engineers to spend significant amount of time in a category 4 suit. And I think that the terminology is category 4 rather than class 4. But otherwise, I often think that the better option is to be using a layering up concept. And now you can achieve a 40 cal. You can achieve 40 cal with 2 super, super lightweight layers. That means that an engineer could be wearing a very, very lightweight, 190 GSM, 5.6 ounce t-shirt, which is around 8.8 cal. And he could combine it with a soft shell jacket, for example, Arc and Flame one, which got 28 cal. And so those 2 garments combined together, we have test certifications for, which are taking you up to 39.5/40 cal. And what that's making is a really, really functional system for the guys to wear when they need to get to those layers, those protection levels, rather than putting on, we may say, the bomb suit. It's there are very light technologies out there now, but it's something the engineers fear. And anything that takes time for the engineers, or anything that could be deemed as hassle, you might be ticking the box from a compliance perspective, but the reality is the guys, ladies, engineers, they're probably not going to use it. I think that's an interesting one to cover. We've worked with the clients recently, one of the largest wind turbine manufacturers globally, and they've gone through an arc flash calculation study with each of their turbine models. And what they wanted to do was to make the collection as safe as possible. They wanted the lightest weight clothing with the highest protection values, but they wanted it to, the guys, before they moved into the Arc and Flame protective clothing perspective, were just wearing regular polyester cotton clothing. What they said was, we don't want to create a huge amount of work or a whole new training piece for the technicians to learn how to wear the new Arc and Flame protective clothing. So what they decided to do was, we could provide a solution that was identical pretty much in weight as to what they were wearing in the regular workwear that they were used to wearing. And so a lightweight t-shirt, lightweight trousers or pants, depending what part of the world you come from. And then what they then said was they needed to layer for higher protection levels, and the highest risk area was in converter cabinets, which every single one of those, pretty much within their turbines, was at torso height. And they said it is not reasonable to expect our engineers to put a one-piece coverall over the top of their clothing, because what you end up with the situation then is you're expecting the guys to do something which is going to take them time. They potentially may have to take the footwear off. It could be a little bit more hot wearing the coverall. What they said was, and they risk assessed, they would expect the guys to just put on the regular soft shell working jacket, which is an Arc and Flame soft shell jacket. And so they gave the protection on the torso only. When I say protection, the higher protection level. Probably not explaining myself particularly well here, but I think the consideration of human factors and what was going to be reasonably practicable for the guys to do was is excellent. And subsequently speaking, is that the whole program has been really, really well accepted by the engineers themselves, and the level of compliance is pretty much 100% because it's easy for the technicians to do. Sorry for the ramble there, Tony, and I hope I've covered and helped you a little bit there. Yeah, thanks, Graham, for putting your email address in there. How does a face shield tying with a layered approach to reaching a 40 cal? I think that's an excellent question, Phil. A really, really good question. I think it's also important to understand, again, the human factors perspective. And if you are working in a vicinity where it's 40 cal, my expectations is the guys aren't spending a long time where the risk there is 40 cal, because whatever head protection you go with, whether it's a helmet with some kind of pull down visor or balaclava to go with that, or whether it's a full hood, you're going to struggle to reach the 40 cal protection without some kind of hood. We brought out a technology which is called a baseball cap hood, which is a super lightweight, and it's literally like wearing a baseball cap, but understandably it's got the hood concept around it, a large screen, which is what we call true color. The benefit of the new true color technologies, this sounds a little bit sales pitch, so I'm kind of getting a bit cautious on, but technologies used to be yellow and green, which meant that when you look through the visors, everything was discolored effectively to a yellow and or green tint. True color technologies means that you have the UV protective tint on the outside, but when you look through the visor, everything is in its true color. So from a 40 cal perspective, on a head and face protection, I don't think you can avoid going with some kind of 40 cal hood. The importance is something that's super lightweight and easy to put on. And engineers, when they understand the risk, so a presentation is shown to them, not that you want to scare them exactly, but I think when they realize how important, of course, the head is to us all, they won't mind slipping on a really lightweight hood. So I think that brings us to the kind of the end of the questions that have been put into the feed. Guys, I really, really, really appreciate the engagement. Thank you for putting it with me. I'm sorry if I've spoken too fast, but unfortunately it's a fallout of being nervous when talking, believe it or not. So I think that we're ready to end the broadcast. Graham's put his email address in there, and I know I keep on pointing to him, but he's my sounding board on anything that's technical when it comes to an electrical perspective, as far as understanding the actual electrical systems themselves, and he's always willing to help everyone and anyone. So with that, I'm going to say good morning, good afternoon, and good night to you all.